Welcome to the Women in AI Research podcast, the show about remarkable contributions of female AI researchers around the globe. I'm your host, Yekaterina, and I'm sharing the mic today with my co-host, Malika. Did you know that the explainability techniques that you're relying on might actually be making human AI teams worse than AI alone?
Now, I'm interested in diving into your research more deeply. We want to explore the central question of when and how much can we trust LLMs? And you've approached it from multiple fascinating angles. Let's start with explainability. When we talk about trusting AI systems, there seems to be an implicit assumption that understanding how they work is necessary for appropriate trust. But your research focuses on supporting human decision making. Do you think we need to understand AI systems to trust them appropriately, or other pathways to trustworthy AI?
Yeah, there are multiple pathways, and this kind of relates in part of the paper where we try to formalize what human trust in AI even means, because it was such a commonly stated statement. We are introducing explainability because it can help gain trust in AI. And Alan Yakovic, who is the first author of that paper, he was like, what does this even mean? And now I'm like, this is a complete digression, but I'm asking similar question right now for, you will see like mechanistic interpretability can help us understand what how models generalize, and it has similar flavor of what does this exactly mean. But going back to your question, in that paper we have basically defined two kinds of trust, what we call intrinsic trust and what we call extrinsic trust. And intrinsic trust is something more associated with what explainability folks mentioned, where you claim people will gain trust in the system if you show how the system reasons about the problem, and if that reasoning is matching what people think of is acceptable reasoning, then they may gain what we call intrinsic trust in this trustworthy system. And this is, we kind of made an analogy with, it is similar if you are trusting a doctor who cites respectable studies, and you do know there are respectable studies, and that kind of matches your expectation of what's trustworthy. But extrinsic trust, on the other hand, you don't need to have any kind of explainability mechanism. This kind of trust you gain when your system is consistently behaving well against evaluation that you find to be trustworthy. And this is similar to a doctor that you trust because they have had a long history of making correct diagnosis. So here, if we had evaluation scheme that we trust, then I'm sure we'll talk about like, what are the evaluation schemes we should be trusting? It's a difficult question. But if we had that, and if our AI system is consistently behaving well against that evaluation, then we would gain the trust in its behavior, despite not knowing exactly the reasons for which it makes predictions.
That's an interesting perspective. I think that currently, like most explainability research optimizes either for technical metrics or human evaluation studies, and your work emphasizes the real world, like decision making, human AI decision making. Can you explain a little bit how, in your view, how that connects to those concepts of intrinsic and extrinsic trust, first of all, and then why you think it is important to move away from those maybe lab settings, more controlled lab settings, into how actual practitioners are making decisions?
Yeah, so I'll just kind of explain this anecdotally that basically when I started my postdoc in 2019, I started to work more on the explainability. And then by the time I was on a job market like 2021, there was a real cloud around explainability and interpretability in terms of do we have any evidence that any of this is helpful to anyone? And it's a question I was asked, and it's a real question, and I couldn't easily say yes or no. But I kind of at that point made it clear for myself that I am in this line of work and I don't know the answer to this question. And I really want to see whether there is any actual benefit and be very open to the idea that there might not be a benefit. There is a paper that we cite in our findings of EMNLP 2024 paper that shows that if you have insights from these proxy evaluations or evaluations that are not application grounded, but they still involve people, you may find something and then with same people and similar setup, run it into real application grounded evaluation and find that your insights completely change. So you can't claim that what we find with these non-application grounded evaluations is aligning with what we would find in real world. So that's where the shift came from me. And that's why I'm like working on a more application grounded evaluations.
Yeah, very interesting. I think the paper you mentioned, is that the on evaluating explanation utility human AI?
That's right. Yeah.
Yeah, that was actually my next question, as I wanted to ask if you could first give us a brief overview of what this work is about and what you to investigate in particular.
Yeah, so it kind of started with this, like goal that I just mentioned of seeing how explanations work in application ground and human-centered evaluations. And we wanted to specifically focus on NLP because that's my research home. And as we started to think about, okay, what kind of evaluations could we do here? Then my student Fatima and I realized that actually it's really hard to even define an experimental setup here. Specifically, there is so many data sets out there. So you would need to choose a data set and a task and then build a model around it and then have some person interact with that model in some way and then show whether relative to them interacting differently with this model, you get benefits or not. That's what you want to show. But choosing a data set and the task wasn't so trivial. I have worked with my collaborator, Sarah, in another paper collecting various data sets that have been proposed for studying explainability in NLP, and we have gathered 50 or more such data sets. And then my student Fatima and I were looking into these data sets, and we were trying to see whether there will be a good choice for us to work with. And that led us to then define criteria for what makes a data set a task in NLP appropriate for studying application grounded evaluation of explanations. And I should mention that means measuring metrics such as whether your participants in your study are appropriately relying on AI, whether their accuracy when they have AI assistance improves, and things like that. And we set those criteria, then we checked, how many of these data sets are actually suitable. And we found that only tiny fraction of them are actually suitable. And then we selected one of them and did some studies for that task.
So that tiny fraction is actually, if I remember that correctly, is just 4 out of 50 data sets, right? Which is
I should
a really small number.
Yeah, I should just mention that we did introduce a criterion which is not crucial for studying reliance and human AI teams. So more data sets survive, but there are still not so many for studying just over reliance. But this last criterion that we stated is basically we should focus on tasks where there is some risk involved. So things where if you build an AI system, then person who is entering this collaboration with that system is actually aware that some hazard might happen when they interact with this system. And then only then, and this is what we state in our formalizing human trust in AI paper, we say only when there is an presence of risk, you can study trust, because you can't study trust because trust occurs when you assume there is risk and you basically are saying, well, all right, I deem this entity to be trustworthy enough for me to expect that it won't hurt me, right? And this is the trust. This is what we are feeling when we trust either other person or an AI system. So we said, okay, let's introduce that another criterion, which means that there should be some risk involved, and only then 4 of these data sets actually are suitable for studying both reliance and trust.
Interesting. What do you think about this work of yours? What does it reveal about the gap between the academic research, academic data sets, academic benchmarks, and practical applications?
Yeah, I mean, I don't think there is some deep truth here than what we all know, that there is a mismatch, right, between setups we investigate and setups that actually are deployed in the real world. But I'll say that I feel like now with LLMs, because they have opened so many applications for of NLP to many people, that evaluations are, when they are focused and done right, they are way more connected to the real world than what we have seen never before, right? Like now, if you go to an NLP conference, there will be a whole section of AI assisted writing, and then there are collaborations with actual companies. And like, I don't know, I'll just mention like someone like Grammarly, and you can feel it's more real than ever before. So yeah, there is of course, a mismatch between like setups we define, because you need to narrow things down to actually make the study feasible. But more and more things are becoming more realistic, I would say. Yeah, I just feel like just like low hanging fruits are done, right? In NLP, and now we are doing more involved kind of evaluations.
Very interesting. So, in particular, I think we mentioned it in previous conversations, but your studies with legal experts revealed some counterintuitive like patterns. Human AI teams often performed worse than AI alone, and experts were hesitant to rely on correct predictions. What does this tell us about how domain experts interact with AI explanations, and how should this change our approach to designing explainable systems, actually?
Yeah. Well, it's a great that we have this podcast format, because I can tell you all the like in between lines explicitly, that you can just slightly hint in the paper. So I think at the end, basically, we kind of are trying to formally say what I'll say now. But basically, I think a lot of these unintuitive human AI team behaviors in our particular setup, where you have legal professionals who are actually good at their job, if you just let them be. If you give them like a task to do and pay them and give them time to finish it, they will do it well. So here, basically, we are introducing AI assistants to more or less speed them up while not losing any of their accuracy and confidence in their decisions. So anytime we are trying to team up experts in some domain with AI assistants, I think we mostly just can then improve their speed rather than their accuracy, because they are very often good at their jobs. When we do these human AI team setups that are super common, this is not specific to our paper, this is human AI team setup that most people are investigating, which is to show people some problem. In our case, that was some statement, a legal statement that had to be verified in the context of some contract that can be pages long. So it's not trivial to do, and some help would be potentially useful. You show people that statement, you show them the contract, and then you show them what some AI system predicts the truthfulness of that statement could be given that contract. You also then, in another setup, can show models explanation for why the model predicts that decision. An idea is that when you contrast the no explanation setup with the explanation setup, if explanation setup is beneficial, then either the human, accuracy on verifying the statement should improve, or it should be the same, but they should be faster, or you should see some benefits, right? And to me, now, after we did all of that, it's a really strange assumption to make, to expect that you will basically, you will speed people if they basically check what AI is doing and they know whether they should go with this decision. But at the same time, you don't want these people to over rely on AI. So they need to engage with this problem just a little bit, right? They need to form some opinion because otherwise they're just going to rely on AI's prediction. So in reality, then you want them to engage with the problem just enough to have some informed opinion, but not long enough that AI assistance is not beneficial, because then they're spending too much time on the problem and they can do the task well. So basically, it's a delicate line we are trying to achieve by, showing them these AI predictions in this way. And I honestly think this setup isn't so meaningful to me anymore, although so many of us have tried it. And this is why in the paper we are proposing other ways we could have human AI teams, such as building automatic deferrals, where you have another model that is learning when your AI is typically could be wrong or correct, and then defers any cases where there is doubt whether this AI system can do it to people. And we have shown in the paper that that kind of deferral is really hard to do because we use reasonable ideas and strong models, but still couldn't achieve good deferral. But if we just assume deferral is perfect, then we saw how better the team's accuracy could be. So I believe that's a very interesting way to go about things. Also, outside of that paper, my student Nate is working on another way of, um, you know, improving human accuracy. And this one can be useful for lay people, where you are automatically finding error types that your model makes, and you make some kind of onboarding protocol and teach people, hey, this is the kind of problems you shouldn't be using AI for. And then you check later whether your people can recognize the cases of those types that you thought that they should not be using AI for, which is another, I think, more meaningful setup to go about human AI teams, rather than just showing people the prediction and hoping they will do everything right, which honestly, I no longer believe it's feasible.
Yeah, that's interesting. And to me, it sounds that it may be not that much even the problem of AI and human teams necessarily, as more or less the problem of any collaboration, whether among people only, or people and AI, or people and I don't know, some other technology. It's about finding that subtle balance between
Yeah.
how much to rely on the other part.
Yeah. And I think if you start from this setting where that achieving that balance is extremely hard, then I think that's not the best setup to, then it's basically like there is a first step of deciding how to like what's the configuration of your AI and people, right? And then if that step is done in a way that makes everything else harder later, that's not a good configuration. And that's kind of where I see this, oh, I have my human just see the prediction and the explanation, and now they need to make sense of everything, be fast, not lose their confidence and not lose their accuracy while being an expert in their field. Which, yeah, I don't know. After doing this study, seems really hard to achieve.
Interesting. Can you say what's that work of your student that you mentioned right now? What's the name of
Nate's-
that paper if it's published?
Yeah, it's not a paper yet. It is currently under review, so I should probably not say its full title. Yeah, check in like a month, and hopefully it's going to be at least on archive. But I will mention some related work. It's called Effective Human AI Teams via Learned Natural Language Rules and Onboarding. This is NeurIPS 2023 paper that basically had executed this idea of teaching people, finding errors automatically, teaching them those people, then checking whether people's accuracy improves. And they have shown improvements for vision tasks, and they have not shown performance for textual tasks. And basically, in our work, which we'll hope to release very soon, is we are looking into why is it's the case that this idea, which seems reasonable, doesn't work for textual task. And that kind of led us to a deep exploration of every stage of this pipeline, where in every stage something could go wrong. And for instance, in this network's work, their final measurement is whether the accuracy of a person improves. But we say that your person potentially totally understood what you were teaching them during onboarding. They understand the problems for which they shouldn't be using AI. But then if later you ask them, hey, solve this problem, and they don't know how to solve them themselves, which is often the case for these MMLU kinds of problems. They're like knowledge problems. I don't know most of them. Then if you're forced to make a decision at the end and you have no idea what the answer is, well, your best guess is then to just say what the AI has said. So in our paper, we say, well, how about changing then the downstream metric to be, can your person recognize whether they should be using AI for this prompt or not? So they should understand, oh, this prompt is of kind of related to that error types, like addition of integers, let's say, and I shouldn't be using AI for that. I'm going to say, no, this is kind of a problem I shouldn't be using AI for. You want to see whether they succeeded in that. And then we see that actually, if you change that downstream metric, we do see improvements from onboarding, but we don't see them if the final metric is accuracy. So yeah, there is still a lot of work to be done just to kind of how to set up these human AI team studies in a way we can appropriately study the benefits of things like explanations.
Very interesting.
I agree. Very interesting. I think following our discussion, one of my favorite tracks of NeurIPS is the position track. And like this reviewing a lot of papers, and there were like most of them were talking about the specific applications of AI, whether it should be like trusted in that specific application or not. And there were one particular paper which was really interesting to me, was about like bidirectional human AI alignment. And I think that's a very nice like perspective, because I think we are entering a very critical era in like AI like ecosystem, and it's very much like the industrial revolution time. And like there are two types of applications of AI: non-AI experts using AI for day-to-day tasks, and AI experts using AI for their day-to-day tasks. And the thing is, in like when we talked about multitasking, I think all of us now have one more task on our list to educate non-AI experts that what the limitations are. And unfortunately, like we usually talk internally with like AI people, and it's good to show that when and how to trust them, and like increase the like general awareness people that
Yeah.
hey, those are the limitations.
Yeah, and it's sometimes to me, it's interesting how intuitive is to a layperson where AI doesn't work. So for us, we all know that arithmetic and math in general isn't something that LLMs are amazing at, right? And it's kind of common knowledge amongst us. So it's really interesting for me, how intuitive to lay people these types of errors LLMs are making is, and that's why I think it has to be done automatically, because as LLMs change, these unintuitive insights also are going to change. But it's really hard. Like I can tell you that finding automatically the error types is hard, and it's even harder to evaluate it because you don't have ground truth, right? Like you don't know what the errors are. So it makes it really hard to frame it as our prototypical machine learning project.
Awesome. That's great. Fantastic. So now let's shift to another aspect of trust, which is very interesting to me: reasoning traces. Change prompting has been celebrated as a window into LLM reasoning, but you've studied whether these traces actually reflect internal computations or not. Someone who works on faithfulness, what's your perspective on the reliability of these like reasoning chains? Should researchers and practitioners actually trust them?
Yeah. Since we just talked about how, experts and lay people have different, insights into what works and doesn't. This is almost like the similar analogy, but like AI experts and then slice of AI experts who works on faithfulness of reasoning traces know that they are not necessarily faithful. And I am surprised that the larger AI community has now started to talk about traces as they are faithful, and that we can now quickly go into things like monitoring LLM behavior by looking at these traces as they are the, the kind of truthful reflection of what the model is exactly doing. So it's interesting that there is this mismatch between people like me working on unfaithfulness of traces and the broader community. But yeah, I mean, it's a fact that they're not necessarily faithful. It's hard to say for me this with utmost certainty, because we don't again have ground truth for faithfulness either, right? That would mean that I can only certainly say whether the trace is faithful and whether my metric of faithfulness is correct if I knew exactly what the model is doing under the hood. And if I knew exactly what the model is doing, then the interpretability is solved, right? And we can all go home and not do anything. So again, there is a good evidence that they aren't faithful from different perspectives. We have different faithfulness measurements. They are saying that chain of thoughts are unfaithful with different rates because these methods differ, and we don't know exactly which one of these methods is the one that's the most correct because we don't have the ground truth. But there is sufficient evidence to say that you can't assume traces are faithful.
Just a quick follow-up question. How do you define faithfulness itself?
Yeah, that's a great question. I would, point everyone to read again Alan Yakois and Yael Goldberg's work on defining the faithfulness. But in general, I think people would say something along the lines that a chain of thought step is faithful if it is associated with the underlying computations of the model, which is kind of vague, but would mean that, for instance, you generate a step, and then maybe now that we have things like sparse feature circuits, you can find features and edges between these features that are connected nicely to that step. So I don't know, maybe if we have something like 5 divided by 4, maybe you have a node for number 5, node for number 4, and node which is associated with dividing relation. And then if you have connections between these nodes, that little subgraph, it is connected to the step. So if you have that connection, then you would then be able to say that the step is faithfully reflecting what's going on under.
I see. Interesting. Let's maybe dive a little bit into the question of reasoning capabilities of language models in general, whether it is about reasoning traces or not. So there is an implicit assumption that as models get larger and more capable, the reasoning becomes more reliable and trustworthy as well. On the other hand, there is a bit of work about the capabilities of language models that are becoming worse when the language model size increases. So, for example, a couple of years ago, there was that the inverse scaling contest where the people were competing on finding the tasks that move into that opposite direction than usual, where task performance gets worse as the size of the language model increases. So you are one of those people that challenges the assumption of the reasoning capability being increased together with the size of the model. Can you tell a little bit about how do you think about the relationship between model scale, capability, and faithfulness of reasoning?
Yeah. So here, maybe I only thing I can offer is a reflection on our paper by again Nate and Oliver, where we have looked into the paper by Anthropic folks that have used their measure of faithfulness, which basically checks when you prompt a model without chain of thoughts just to get the direct answer, and then you prompt it to also produce a chain of thought, whether the answer changes or not. And they say, well, if the answer didn't change, then the chain of thought didn't make enough influence on the answer. So they deemed the chain of thought to be unfaithful, which is a notion of faithfulness I don't really agree with. And some other people don't too. There is a paper by Letizia and my PhD advisor, Annette, on how this is more something like self-consistency. So I welcome you to check that out. But assuming that's a measure of faithfulness, what I then showed is that if you plot their faithfulness, and on y-axis and x-axis you have various sizes of models in a number of parameters, they basically found with their metric very high faithfulness for very small models. And then it was decreasing to model size of, I think, 13 billion. And then it started to increase again, which suggested that very small and very large models are producing chain of thoughts that are more unfaithful to the models underlying computation. And that already to me was a little bit suspicious because very, very rarely we see such nice regularity in ML research, right? So seeing that really 13 billion is that magical number where everything seems to be great just didn't seem right to me. So we did a little further inspection and basically we tweaked their measurement just slightly so by accounting for how often a model would change its answer if we just shuffle the order of answer options. And I should have mentioned this was all done for a multiple choice question answering. Because you know that models, especially smaller models, exhibit position bias, right? So they don't know what the answer could be, they just maybe pick the first option. So when you do that, the unfaithfulness of very small model decreases notably, and then you basically get something which is mostly increasing, which suggests that at least the smaller models aren't that, you know, their chain of thoughts aren't so unfaithful as it might seem. I mean, their chain of thoughts are just rubbish. It kind of checks out. And it also shows that there isn't that magical number. But also, to me, just seeing that graph that where unfaithfulness is increasing also didn't seem intuitive. Because if you have played with ChatGPT, which I assume you have, and everyone listening this, you know that the kind of explanations you're getting are very plausible, right? And we know that there is no relation between plausibility and faithfulness. These concepts are not necessarily aligned, but it just seemed a little bit too strange to me that with scale, I believe the plausibility increases. We don't have that plot. I'm just anecdotally telling that. And then you have, okay, unfaithfulness is also increasing, which would mean that as the models get larger, because their unfaithfulness is higher too, they are then with higher rates using something else than this plausible reasoning, and at the same time being better performing. So basically, they are fitting some shortcuts and still behave much better at most tasks. It just doesn't, it just doesn't seem intuitive to me. And we did this correlation with accuracy, and we did see that more accurate your model, more seemingly unfaithful its generations are. So I still find that to be not then something I would be comfortable saying, that the larger the model is, that more unfaithful its chain of thoughts are. And this is just anecdotally from my own intuition. But then this also set this new line of work with Martin Tutek, who led the work on first attempt of trying to measure faithfulness of chain of thoughts, with where we don't do these behavioral studies where you tweak the input and then you check whether output changes, but rather, since the whole concept of unfaithfulness is tied to model internals, you're asking whether this step is associated with model computations internally. We started to look what's going on internally with these steps. And this is the first attempt to do that. We have used unlearning methods to basically unlearn a step and then see whether the predictions are changing. And then we find that the unfaithfulness we get is not so high as these behavioral methods are reporting. Yeah, I'm gonna stop here. I had a very long answer to your question.
That was great, actually. Yeah, like following what you said. So the findings you mentioned mainly about like faithfulness are from
Mhm.
the thought on faithfulness as disguised
Yes.
security people, right? So what question? The question I have is like there was a hype last year, really 2024, and even now that like small language models can be good replacements in some like domains for like large models. So how do you think we can keep the balance for like faithfulness, accuracy, model performance, reasoning, and like to like I don't know to address this with just like small language models? And do you think if there is need to scale up the parameter size to those large models that like billions of dollars on just like training these big models?
Yeah. So it depends whether a question is about reasoning language models specifically or just LLMs, because I teach other professors who are outside of computer science what LLMs are and how they can meaningfully use it. And I basically show them little like tree structure that I have built where I'm like, all right, you have your problem. Do you have some data for this problem? If you have some data for this problem and you can frame it as a classification problem, you might be better off using a smaller model, fine tuning on your data, and being more in the control of what this model is doing, being more specialized for the exact task you want to do. So I kind of discourage them also to just jump on prompting for every single thing they want to do. Sometimes it's honestly there is so much resources of how to run this code, and with things like Cloud Code, they can just do it themselves, even if they don't have ton of coding experience. And we kind of go through a little exercise where I try to convince them they can run some Python code. So for me, I'm always trying to encourage them to use something that's simpler and more feasible and more specialized for their task. Now, in the realm of reasoning language models, there is also a question, do your problem requires like deep reason, right? Like if you use GPT-5 today, I get a little bit annoying when it defaults to the thinking mode and it's thinking 5 minutes for something that I find, no, just go to that previous version, like you need to think about this too long. Like this is not a reasoning problem. So I don't think we need reasoning LMs for every single thing we are trying to do. So again, I would discourage people from using reasoning language models for some problems. But now if you think about problems where reasoning might be necessary, maybe we are doing some agentic stuff. And now if we focus on that setup and ask whether smaller reasoning LMs could be as good as the large LMs, I think it's also important to state that what's the actual difference. Like if they're trained in the exact same way, then it's more likely your larger reasoning LM will be better, right? But the smaller reasoning LMs usually now are using some kind of smarter data distillation and similar situations. So it's not exactly, I would say, apple to apple comparison because we didn't create these two models in the exact same way. But you could definitely produce smaller reasoning LMs for your problem. And honestly, that's a much better way to go, in my experience, working these days with web agents where there is just so much querying of your LM that things can get really expensive if you are prompting just the largest, best model with APIs. And sometimes that's honestly not a feasible solution, especially if you are building a product around that reasoning LM where you will be querying a lot of times. And that's my experience. I wouldn't call myself an expert on reasoning language models. So someone might say like, I don't agree with you, and I would totally be like, yeah, the checks out. Let me hear what do you have to say about that. So I want to acknowledge them.